Greetings from Mahajabeen. This is Mahajabeen from ECE department. I'm going to discuss on fundus image enhancement method based on cycle GAN. So here's an abstract. So it is basically called uh, retinal image enhancement method, also called as cycle CBAM, which is based on cycle GAN to realize a migration from poor quality fundus image to good quality fundus images. The experiments show that our method of integrating CBAM into cycle GAN has superior performance that cycle GAN both in quantitative and qualitative results. The retinal fundus images are the most effective and basic way to screen the common eye diseases. With the development of computer aided diagnosis and the popularity of portable fundus cameras, many intelligent eye disease diagnosis systems have been applied to early screening of DR. The clarity of the fundus image is prerequisite for the correct diagnosis of the intelligent system. The above figure shows the fundus images with blurring and insufficient illumination with limit the analysis and diagnosis of fundal images. The contrast enhancement algorithms for retinal fundus images can be roughly divided into three categories, namely data domain methods, restored to model methods, and learning based methods. The data domain method is method of enhancing the input images without prior knowledge and pre-training model, including the image domain algorithm and the transfer domain algorithm. Enhancement method that can be process blurry images based on fusing basic information of background with original retinal image. Restored model methods are mainly based on the parameter estimation of target image domain. In the study of Xiong, the fungus image is formation model of scattering is created by estimation and parameters of the model background illuminance. In the field of dehazing, cycle dehaze is proposed based on the generative adversarial networks. This end-to-end network reduces the estimation of intermediate parameters. The GAN, which is also called as generative adversarial networks, was proposed by Goodfellow because of its superior performance in image generation tasks. The idea has been extensively studied and used by many scholars. However, this method is not suitable for the enhancement of retinal images because it is difficult to obtain a large number of medical images. It is obviously unrealistic to obtain a pair of fundus images of same patient with clear or and poor quality. Proposed method. Our goal is to learn a mapping form from a source domain A with low illumination and blurry retinal images to the target domain B with clear retinal images. The input of new network are unpaid training image sample. Convolution block attention module. C. Cycle CBAM. CBAM is lightweight and general module. It can be integrated into most CNN architectures seamlessly with negligible overheads and is end-to-end trainable along with base CNN. Comparing to cycle GNN, we aimed CBAM in each rest block of the two generators G and F of cycle CBAM. Cycle CBAM has the same loss function of cycle CGAN, and our goal is to solve this. The given form here: image A, fake A, cycle B, cycle A, generator. Here is how the retinal images are formed. Diabetic retinopathy classification network. Because the test set is obtained by artificially degrading high quality images selected by professional doctor PSNR and SSIM cannot fully measure the enhancement effect of cycle CBA. In order to verify the enhancement effect of our method, we introduce Inception Resonant V2 network as a DR classification module to classify the DR grade of the fundus images before and after enhancement. Implementation details: we use PyTorch framework for the training and testing phases and train all the modules on an NVIDIA RTX with 11 GB GPU memory. We exploit a batch size of 1 and Adam optimizer with learning rate of 0.0002 in training. In the first 50 epoch, we keep the same learning rate. Then we linearly decay the learning rate to 0 over the next 100 epochs. During the test stage, in the case of using a GPU, it takes an average of 1 second per image, and in the case of using an Intel Core CPU, each image takes about 6 seconds. The results and experiments. In this section, we show the enhancement results of cycle CBM on the test set and compare it with the cycle GAN. Convolution block attention module. This is the block diagram for CBAM. Input feature, refined feature, and it is connected in between with channel attenuation model, spatial attenuation model. The results. We verify our method on the test set selected by professional doctor and compare our method with the other state of art approaches. We presented an end-to-end network of retinal images. Our method cycle CBAM can realize a migration from poor quality fundus picture to good quality fundus picture. Thank you.